This is a 4-bar mechanism. If I take this parallelogram and I just invert it, I get a hinge, and this is a model of what happens in the human knee joint. These two blue bars represent the cruciate ligaments, and these black bars represent the bones in the leg, and the ligaments guide the joint. It's a very elegant design in the human knee joint. Now, every engineer knows that you cannot evolve a 4-bar mechanism step by step because you need 4 bars and 4 pins simultaneously. You can't just have 1 bar and evolve it because the mechanism would not have a useful function until all 4 bars are there together. This is a classic example of what's called an irreducible mechanism. That is a mechanism that needs all parts to exist simultaneously, otherwise the mechanism cannot work. You've got to have these 4 bars and these 4 pins existing at the same time for the mechanism to work. And this is also an example of a mechanism that biologists find difficult to even identify, yet alone understand, because they're not trained in mechanics or engineering design. I think the chances of the 4-bar mechanism in the knee joint appearing by chance are 0, because if you take, for example, a simple hinge joint like the elbow joint, it has very simple ligaments. In the case of the knee, the ligaments are inside the joint, they're crossed, and there are just too many changes that you have to make simultaneously for that to appear by chance.